Well, how's everybody doing out there? Well, welcome to day 16 of Corona Online School. So we've actually just hit the halfway mark of the semester. So good job, everybody. You guys are doing a great job. So hang in there. So technically today on the syllabus, we were supposed to be doing a measurement lab, which I'm not sure if I'm going to be able to recreate. So I'm going to go ahead and actually move on to the next section and we'll see if I can come up with some way to recreate something similar at home, but it's not looking good at the moment. So instead, we're just going to move on to area and perimeter. And so we're going to study area and perimeter of lots of different shapes to try to come up with formulas for these different shapes and things like that. So just as a quick reminder, so perimeter is kind of measuring the outside of the area. So if you were thinking about like a fence, like the amount of fence you would need to surround a certain shape would be the perimeter. So it's the measure of the outside. And so it would basically be the amount of fence needed to fence in some shape. Where the area is the amount of side, the amount inside the fence itself. So it's the amount of space inside the fence. Whoops. And so, like, the amount of fence would be measured as, like, feet, say, for example, but the amount of space inside the fence would be measured in feet squared. Because what we're doing is kind of calculating how many 1 foot square tiles we could actually put inside of that fenced in region. So, the goal is you're going to kind of go through, I'm going to kind of leave you on your own to do most of this. So, for all these, they have little practice problems where it suggests, make a certain size rectangle, see if you can calculate the area, the perimeter, come up with what the formula for the area of the rectangle could be, and then use this doing some other shapes. Now I do want to talk about area polygons real quick. So what I've drawn on the board here, on the paper for you, is what's called a geoboard. And I'm not sure if you guys have used these or seen these before, but they're very cool. And there's some nice apps that you can actually use. So I've downloaded one here that I'm going to show you, which is really, really nice. And so this is kind of a typical geoboard. And if you notice at the bottom left, you can actually change the sizes of it. So I can make it a big rectangle. I can make it a circle. And so, but for right now, I'm just going to make it into a little square. And so the idea is in the classwork packet, like, and you might want to download something like this, or if you at least Google Geoboard, there's ones you can use on your computer if you don't want to download the app. But if you look, I want you to construct 6 different polygons, one that goes in each of these boxes. So they could be concave, they could be convex, but I want them to be unique. So not like, a rotation of one or something like that. And so for practice 2, we're going to make the area 3 square units. And then for the practice 3, we want the area to be 2.5 square units. So the nice thing is if you use the geoboard, like you can make some mistakes and try some stuff out, and then once you know you got it right, then you can kind of sketch it down. So one of the other hints to remind you when you're using the geoboard, if we're trying to make something that's 3 square units, so if I grab the rubber band there, so if I grab it in the middle, that allows me to take it to another dot, and then I can grab it down here, and that takes it to another dot. So in this case, like this would have an area of 1 because it's just 1 square unit. But the perimeter would technically be 4 because I've got 1, 2, 3, 4 sides. So the perimeter would be 4, the area would be 1. And so in this case, so if I wanted an area that was 3, then what I'd want to do is kind of drag this guy down like this. And then if you want, you can put rubber bands in here just to kind of show the different sections. So now I've got 3 distinct boxes. So that's going to give me my 3 square units of area. And then if I were to count the perimeter, again, I'm just going to count the insides. I'm not going to count these rubber bands in the middle because they're not on the outside. So my perimeter would be like 1, 2, 3, 4, 5, 6, 7, 8 in this case. So this would be a unit or a diagram that has 3 square units. Now for me to do a 2.5, that means I'm going to need something like, whoops, like this. I'm going to have a triangle in there somewhere. Now granted, I can have triangles in the 3 square units too, as long as I have 2 triangles that add up to a whole. But the only way I'm going to get a half is if I get a triangle in here. So this is like an easy example of a 2.5 area unit that, and then again you could calculate the perimeter and stuff like that. So again, the GeoBoard makes it nice because that way, like, you don't have to draw it on the paper, mess it up, and erase it 100 times. So maybe do download the app or go to the website and Google GeoBoard so you can actually play around with the app a little bit. The app is nice because again, like, you can make these, but then there's the possibility of everybody shooting each other with rubber bands, which is probably never a good thing. So at least this way, no one gets to lose an eye from a rubber band or anything. And you got all kinds of different colors, and you can write on it and stuff like that. So that way, I could have wrote, the 1, 2, 1.5. So that was my 2.5 area and stuff. So this is a nice app. It's pretty cool. Again, it's free. There's nothing, I try to show all my apps that are free if possible. So that's the GeoBoard. So if you get stuck or have any problems messing around with the GeoBoard, just let me know. Otherwise, I think the rest of it's pretty self-explanatory. So you're just going to go in, figure out what the formula for the area of parallelogram is. So again, follow the steps. Ask me questions if you get stuck. Area of a triangle, same thing. Follow the steps. If you get stuck, let me know. Area of a trapezoid, again, same thing. Follow the steps. Let me know if you get stuck. And then finally, some applications, putting everything together, And then again, here's an addition property. So again, it allows you to divide weird shape up into shapes that you actually know the areas of. And then you could add the shapes together, and that'll give you the area of the whole shape, which is kind of cool. And then finally, again, just a lot more practice. So again, when you're working on these, just let me know if you get stuck or if you have any questions. Remember, the main thing on this last practice is keep in mind the units. So in this case, like the first one, since everything's in millimeters, our perimeter is going to be millimeters, but our area is going to be millimeters squared. So the area is always the square. The perimeter is always just the plain old units and stuff. But again, have fun working on these. These are pretty cool. If you get stuck, just let me know. I'll be around the computer all day. So good luck.